Somewhere in the western Atlantic Ocean, roughly between the coast of Florida, the island of Bermuda, and the shores of Puerto Rico, there is a stretch of sea that has spent decades collecting a very particular kind of story. Ships that left port and never arrived. Aircraft that sent a final transmission and then went quiet. Crews that were never found. This region, loosely sketched as a triangle on a map, has become one of the most talked about and most debated patches of ocean on the planet. Welcome to Slumber Sea. Tonight, we are drifting into the mystery. The area most people call the Bermuda Triangle takes its rough shape from 3 points. Miami on the Florida coast forms the western corner. The island of Bermuda sits far out in the Atlantic to the northeast, and San Juan, Puerto Rico, anchors the southern tip. Draw lines between those 3 points, and you have captured the general idea, though the boundaries have never been officially drawn by any government or maritime authority. The triangle exists more as a concept than as a formally charted zone, and even the estimates of its size reflect that looseness. Depending on who is measuring and where they draw the edges, the region covers somewhere between roughly 500,000 and 1.5 million square miles of open ocean. That is an enormous range, and it tells you something important right from the start about how much of what surrounds this place is defined by storytelling rather than precision. The stories themselves are genuinely compelling. Popular accounts claim that more than 50 ships and over 20 aircraft have disappeared within this triangle over the years, many without explanation, without wreckage, and without survivors. Those numbers have a way of settling in the imagination. 50 vessels, 20 aircraft. People aboard each of them who set out on ordinary journeys into waters that looked, from the surface, like any other part of the Atlantic. And the Atlantic in this region is deeply, constantly in motion. Warm currents and shifting winds, tropical weather that can build from nothing into something serious in a matter of hours, and a seafloor beneath that is far from uniform. The Bermuda Triangle sits over water that ranges from shallow tropical shelves near the Bahamas to some of the deepest open ocean trenches on Earth. If something does go down out there, finding it is not simply a matter of knowing approximately where to look. But here is the question that sits at the center of everything we are going to explore tonight. Is this stretch of ocean genuinely and uniquely dangerous in some way that science has not yet fully explained? Or has a legend grown so large and been repeated so many times that it has long since outgrown whatever evidence it was built on? That is not a question with a single, simple answer. The story of the Bermuda Triangle turns out to involve many different threads woven together. There is history, and some of the individual disappearances in these waters are genuinely mysterious by any reasonable accounting. There is environment, because the natural forces at work in this part of the Atlantic are real, and they are formidable. There is human judgment, because many of the incidents that built the legend occurred in an era before radar, before GPS, and before the kinds of weather forecasting that modern crews take entirely for granted. There is statistics, because researchers have now gone back through decades of maritime and aviation records and asked whether the numbers actually support the idea of unusual danger, and what they found may surprise you. And there is media, because the modern shape of this legend was very deliberately assembled, packaged, and sold to a public that was more than ready to believe it. Charles Berlitz's 1974 bestseller gave the myth much of its current form, gathering earlier reports and disappearances into a single sensational narrative that spread widely and quickly. But the waters themselves had been gathering a darker reputation long before that book arrived. So tonight, as you settle in, we are going to move through all of it slowly and carefully. We will look at what actually vanished, what the evidence suggests happened, and what the data collected over many decades now tells us about whether this triangle deserves its reputation or whether it is, in the end, a story that found the ocean it needed. The Atlantic is patient. It does not argue. It simply continues, deep and dark and largely indifferent, while the rest of us decide what to make of it. The story did not begin with a single dramatic moment. It accumulated slowly across more than a century in the way that all legends do, ship by ship, flight by flight, across long stretches of time where each incident might have been forgotten on its own. But together, they formed something that the imagination could hold onto. The earliest losses connected to this region date back to the 1800s, when American naval vessels were still made of wood, and navigation relied on celestial observation and the judgment of experienced officers working with instruments that gave only approximations. The USS Pickering vanished in 1800 with 91 crew members somewhere in the Western Atlantic. The USS Wasp disappeared in 1814, taking 140 souls with it into waters that offered no explanation and left no trace. The USS Wildcat was lost in 1824 with 14 men aboard. These were not mysterious in any supernatural sense. Ships were lost regularly in that era, in every ocean, under conditions that modern sailors would consider barely manageable. But they were losses in this particular stretch of water, and they would eventually be folded into a larger list that kept growing. It is worth pausing here to acknowledge something that matters. Early ship loss records from the 19th century depend on incomplete logs, limited communication, and records that were not always preserved carefully. The exact locations, the precise crew counts, the specific circumstances of those early disappearances are sometimes approximate at best. That caveat applies to quite a few of the cases that have ended up on various lists of Bermuda Triangle incidents over the years, and it is something we will return to. But then came a loss on a different scale entirely. In March of 1918, a United States Navy collier called the USS Cyclops left Barbados carrying a cargo of manganese ore and 306 crew members and passengers. The ship was large, experienced in transatlantic service, and had no known reason to be in distress when it sailed. No storm of unusual severity was recorded in its path. No distress signal was ever received. The Cyclops simply ceased to exist, as far as anyone could determine, somewhere between Barbados and Baltimore. It never arrived. No wreckage was recovered. No bodies were found. The Navy investigated and reached no firm conclusion. To this day, the loss of the Cyclops remains the largest single non-combat loss of life in the history of the United States Navy. 306 people, gone without a word. That number is worth letting settle for a moment. 306. The Cyclops became a cornerstone of the Triangle's growing reputation, precisely because it resisted explanation. Investigators could not point to a rogue storm, a navigational error, or an enemy action that fully accounted for what happened. The absence of an explanation left room for other kinds of speculation, and that room has never fully closed. Then came the 20th century's most pivotal episode in the making of this legend, and it arrived not from the sea, but from the sky. On the 5th of December, 1945, 5 United States Navy TBM Avenger torpedo bombers took off from Fort Lauderdale, Florida, on what was designated as a routine training exercise. The flight was known as Flight 19, and it carried 14 airmen led by an experienced instructor. What happened over the following hours has been reconstructed from radio transmissions that grew increasingly confused as the afternoon wore on. The flight leader reported that his compass was behaving strangely. Transmissions suggested the pilots were uncertain of their position, possibly disoriented over water they believed they had already passed. The radio contact fragmented and then went silent. Flight 19, all 5 planes, all 14 men, simply disappeared over the Atlantic. And then the search began, and the tragedy deepened. A PBM Mariner rescue aircraft with 13 crew members was dispatched to locate Flight 19. It too sent a final transmission and was never seen again. 27 people lost in a single afternoon over waters that, on the surface, appeared entirely ordinary. The 1945 incident became central to Bermuda Triangle storytelling for reasons that go beyond the numbers, significant as those numbers are. Flight 19 had the quality of a mystery story told in real time. There were radio transmissions. There were experienced pilots who expressed confusion about where they were. There was no wreckage recovered from most of the aircraft. No tidy explanation delivered after the fact. The Naval Board of Investigation offered various possible causes, but reached no definitive conclusion. That open ending was exactly the kind of space into which a legend could expand. Subsequent decades added more material. A C-119 flying boxcar disappeared in 1965. The British passenger aircraft Star Tiger and Star Ariel were lost in 1948 and 1949 respectively, the disappearances adding a transatlantic dimension to the growing catalogue. Each new case arrived in the press with references to the cases before it, and the pattern that no pattern should rationally impose on scattered accidents across decades of maritime and aviation history began to feel in the telling like a pattern nonetheless. It is important to be honest about what that list actually contains, because this is where the construction of the legend becomes visible if you look carefully enough. Some of the cases cited on various Bermuda Triangle incident lists are disputed or poorly documented. The story of the Ellen Austin from 1881, which describes a crewless derelict ship found and then lost again under strange circumstances, lacks contemporary newspaper confirmation and is now considered by many researchers to be largely folkloric. The Star Tiger and Star Ariel disappearances, which genuinely occurred, have plausible conventional explanations that thorough investigations suggested at the time. Including uncertain cases alongside well-documented tragedies, inflates the sense that something extraordinary and consistent is happening in these waters, when the reality is considerably more scattered and complicated. But legends are not built on careful curation. They are built on accumulation and selective emphasis, on taking the strangest details from many separate events and weaving them together into something that feels coherent. The Bermuda Triangle, as most people understand it, is in large part a product of that kind of retelling. where incidents separated by decades and hundreds of miles get grouped under a single name that implies they share a common cause. That grouping continued well into the 21st century. In 2017, a small MU-2B private aircraft vanished from radar over the area, with wreckage eventually recovered, but the circumstances of the loss still serving the story. A Turkish Airlines flight the same year experienced electrical problems over the region and was forced to divert, which made news partly because the triangle's name attached itself to the event almost immediately. And in May of 2023, an 18-year-old named Cameron Robbins fell overboard from a cruise boat in the Bahamas. The Coast Guard suspended its search after several days. His disappearance was a genuine tragedy, and it was also, in a matter of days, folded into the Bermuda Triangle narrative in the way that tragedies in this part of the ocean almost inevitably are now, regardless of what the evidence actually suggests about their cause. That is the pattern that built the legend. Not a single catastrophe, but a long, slow accumulation of losses, genuine and disputed, documented and foggy, each one reinforcing the one before it, until the very act of searching for an explanation began to feel like evidence that there was something unusual to explain. The waters had the incidents, the storytellers had the framework, and between those two things, the Bermuda Triangle became what it remains today. So, we have the legend, carefully assembled across more than a century of incidents, real and embellished, and it is a compelling one. But there is another way to look at these waters, one that involves not individual stories told with dramatic emphasis, but the quieter and less emotionally satisfying work of counting. The numbers, when examined with care, tell a rather different story. In recent years, researchers took a straightforward approach to the Bermuda Triangle question. Rather than cataloguing the most famous disappearances or weighing the most dramatic theories, they turned to the kind of raw data that tends to resist embellishment. A study drawing on United States Coast Guard marine and aviation casualty records spanning 1982 to 2015 examined a total of 9,096 incidents recorded across the world's oceans. Of those, 361 occurred within the boundaries of the Bermuda Triangle. That is roughly 4% of the total. And when researchers looked specifically for incidents classified as disappearances, the kind of event at the very heart of the Triangle's reputation, they found none within that 361 event subset during the study period. Not a statistically unusual cluster, not a pattern pointing towards something hidden, just incidents distributed across ocean space in the way that incidents in heavily traveled regions tend to distribute themselves. The conclusion drawn from this analysis was precise and somewhat deflating if you arrived hoping for confirmation of something stranger. The Triangle's incident frequency matches global averages. There is no statistical excess of mysterious losses. The numbers simply do not support the idea that this particular stretch of ocean swallows vessels and aircraft at any rate beyond what you would reasonably expect from a region that sees the traffic volume it does. And this is worth pausing over, because the traffic volume matters enormously to how we interpret the raw count of accidents. The area between Miami, Bermuda, and Puerto Rico is not a remote and rarely crossed corner of the ocean. It is one of the busiest maritime and aviation corridors on the planet. Commercial shipping routes connecting North America to the Caribbean, to South America and to Europe pass through these waters. Pleasure craft travel constantly between Florida and the islands. Commercial flights cross overhead in numbers that would have seemed extraordinary even 50 years ago. When you place a very large number of vessels and aircraft in any given stretch of ocean over any given span of decades, some of them will encounter difficulties. Some will be lost. The sheer volume of movement through this region will naturally generate a proportionate volume of accidents, and that proportionality is exactly what the data appears to show. Not more incidents than expected, not fewer, simply what the traffic warrants. The National Oceanic and Atmospheric Administration, one of the principal authorities on ocean science in the United States, has addressed this directly. As cited by Encyclopaedia Britannica, NOAA's position is unambiguous. There is no evidence that mysterious disappearances occur with any greater frequency in the Bermuda Triangle than in any other large, well-traveled area of the ocean. That is an official scientific finding, not a dismissal offered without examination. It is the conclusion that emerges when the question is treated as a question about data, rather than a question about legend. There is, however, an important caveat here, and intellectual honesty requires acknowledging it before moving forward. The Coast Guard dataset at the center of the statistical analysis is primarily built around US registered vessels and American aviation records. It reflects, in large part, the incidents that American authorities were positioned to document, investigate, and report. Non-American vessels crossing these waters, ships registered in other nations, private craft from dozens of different countries may be underrepresented in that record. Some incidents involving foreign vessels could have occurred without generating entries in the databases used for comparison. This does not overturn the broader finding. It does mean that any precise frequency comparison carries a degree of uncertainty, and that the picture, while reassuring in its general shape, may not be perfectly complete. Science tends to work that way. It offers the best available conclusion from the available evidence while acknowledging the boundaries of what that evidence can actually show. What the data does do with reasonable confidence is shift the burden of explanation. For decades, the assumed question was why so many things go wrong in the Bermuda Triangle. The numbers suggest the more accurate question might simply be why anything goes wrong at all in any heavily traveled stretch of ocean, which is a question with considerably more mundane and instructive answers we will come to shortly. None of this, it should be said, dissolves the emotional weight of the individual cases. The families of those lost on the USS Cyclops are not consoled by a statistical chart showing that cargo ship losses in the early 20th century were a broadly distributed global phenomenon. The airmen of Flight 19 do not become less real because their disappearance fits within a frequency that researchers consider unremarkable. The data addresses the question of whether there is something anomalous about this region of ocean. It does not address the grief or the unanswered questions that belong to each incident individually. What it does do is gently remove the scaffolding from a particular kind of explanation, the kind that requires the ocean itself to be behaving in ways that defy ordinary understanding. The numbers do not support a portal, a vortex, anything that operates outside the physics we know. They support something considerably less dramatic and considerably more useful, which is the possibility that if we want to understand what happens to ships and aircraft in these waters, we should probably look at the actual conditions those ships and aircraft encountered, the weather, the waves, the geography, and the decisions that human beings made under pressure. And that is where the story becomes genuinely interesting, drifting now toward the hidden forces that these waters genuinely do contain. If we set aside the idea of a uniquely cursed patch of sea, what remains is, in some ways, more humbling. The Bermuda Triangle is not an exception to the laws of nature. It is a vivid example of them. It sits in a place where powerful atmospheric engines, complex ocean dynamics, and the subtleties of Earth's magnetic field all come together. None of these things are supernatural. All of them are quite capable of turning a voyage or a flight into a desperate struggle. Begin with the surface of the water itself and the ways it can betray the expectations of those who travel over it. For a long time, sailors' tales about walls of water rising from an otherwise unremarkable sea were treated as exaggerations, or as the kind of stories that grow taller in the retelling around a harbour bar. Then, in the closing years of the 20th century, instruments began to confirm what human eyes had been seeing for centuries. Out in the North Sea, a wave now known as the Draupner wave was recorded at around the 26 meters, about 85 feet high, towering over the background swell. Off the coast of the southeastern United States, NOAA has documented rogue waves reaching roughly 18 meters, around 60 feet. And from these and other measurements, oceanographers have concluded that in the right conditions, what they sometimes call monster waves of nearly 30 meters, close to 100 feet high, are physically possible. A rogue wave is not simply a big wave in a storm. It is an event in which several different wave systems, driven by winds and currents moving in different directions, briefly align. Their crests add together instead of cancelling each other out, and the result is a single, steep, towering wall of water that can rise more than twice as high as the surrounding sea. Just as quickly, it disappears back into the pattern, leaving only whatever damage it has done. Imagine encountering that in a heavy cargo ship, let alone in a smaller freighter or a fishing vessel. The force of water scales dramatically with height, and a breaking wave tens of meters tall can smash windows, twist metal, and sweep decks clean in an instant. A ship caught side on might capsize. A vessel already stressed by age, cargo shift, or earlier weather could be catastrophically weakened. No unknown energy is required. 100 feet of moving water will do. The waters of the Bermuda Triangle sit on the path of powerful currents and beneath a sky where strong winds are common. Rapidly changing wave fields, intersecting swells and long fetches where the wind can build seas over many miles, all help create the conditions in which rogue waves are more likely to form. They are rare at any single point, but not impossible. And when they do occur, they leave little direct evidence. A ship might radio a brief distress call mentioning huge seas, or a freak wave, or might say nothing at all before its signal simply ends. Now lift your attention from the surface of the water to the sky above. The triangle lies in the heart of the Atlantic hurricane belt, a region where warm ocean water acts as fuel for some of the most powerful storms on Earth. Each summer and autumn, disturbances roll off the coast of Africa, cross the Atlantic, and, if conditions align, spin up into tropical storms and hurricanes that curve toward the Caribbean, the Bahamas, and the southeast coast of the United States. These systems are not gentle. They bring sustained winds that can exceed 100 miles per hour, towering cloud decks, torrential rain, and rapidly changing barometric pressure. When researchers looked closely at decades of United States Coast Guard marine casualty records, they found that incidents in the Bermuda Triangle were strongly correlated with tropical storm activity. In statistical terms, the relationship had a Pearson correlation coefficient of about 0.71, with a high level of significance. In more everyday language, when tropical storms and hurricanes are active, marine accidents in this region become notably more likely. The reasons are straightforward when you picture what it would have meant, particularly in the decades before satellite weather imagery and modern forecasting tools, to be at sea as one of these systems intensified. A captain might have only barometer readings, cloud formations, and reports from other vessels to guide decisions. A storm could shift its track overnight. A ship that believed itself to be safely clear could, by morning, find itself on the edge of hurricane-force winds, with visibility collapsing and seas building over the course of a few hours. Inside such a storm, individual waves can combine on top of the already high seas, creating the rogue events we have just followed. Wind-driven spray strips the air of visibility. Rain sheets down so heavily that the horizon vanishes. Lightning, turbulence, and severe downdrafts create danger for aircraft as well as ships, particularly for earlier generations of planes with more limited instrumentation. When accidents happen under these conditions, they can easily feel from a distance as though something inexplicable occurred. A ship reported moderate seas and then went silent. An aircraft transmitted a routine position update and failed to arrive. The missing piece in those bare narratives is often the speed with which conditions can deteriorate in hurricane-prone waters. What was moderate at noon may be life-threatening by dusk. From towering waves and violent storms, move now down below the surface again into the sea floor itself and into one of the more speculative ideas that has been associated with the Bermuda Triangle. Beneath many continental margins, including parts of the Atlantic, there exist deposits of what are known as methane hydrates. These are icy crystalline structures in which methane gas is trapped inside a lattice of water molecules. They are stable only under specific combinations of pressure and temperature, such as those found in cold, deep marine sediments. The methane hydrate burp hypothesis suggests that if these deposits are destabilized by changes in temperature, pressure, or seafloor slope, they can release large volumes of methane gas suddenly into the overlying water. Laboratory experiments and observations from places like the seabed off Norway have shown that rising plumes of gas bubbles can reduce the density of the water through which they pass. In a controlled setting, models and tank tests have suggested that if a ship were to find itself directly above a dense, actively bubbling column, its buoyancy could be compromised. The vessel might sit lower in the water, or in an extreme scenario struggle to stay afloat. Methane rising into the atmosphere could also, in principle, interfere with aircraft engines if the concentrations were high enough and the plane low enough. These ideas are scientifically interesting, and they illustrate that the ocean floor is not a static, inert platform. It can, under some circumstances, change suddenly, releasing gas or slumping in underwater landslides. However, It is important to be very clear about the status of this hypothesis as it relates to the Bermuda Triangle legend. Although methane hydrates exist in many parts of the world's oceans, including the North Atlantic, there has been no direct documentation of a large-scale gas release in the triangle coinciding with a ship or aircraft loss. The tank experiments that show ships losing buoyancy occur under controlled, often extreme conditions that may not scale neatly to the open ocean. National Geographic, in discussing this theory, has emphasized precisely this point. The effect is plausible in principle and demonstrable in the laboratory, but its real-world impact at the scale of entire vessels in deep water remains speculative rather than proven. In other words, methane hydrate burps may be one of several exotic possibilities, but they are not established as a common or dominant cause of disappearances in any ocean region, including the Triangle. The more solidly grounded invisible force at work in these waters is not gas, but magnetism. Most of us move through the world with the idea that a compass simply points north, and that this north is a fixed, obvious reference. In reality, Earth's magnetic field is lumpy and shifting. Magnetic north is not located at the geographic North Pole, and the difference between where a compass points and true north is known as magnetic variation or declination. Navigators have long had to correct for this, using charts that show how many degrees east or west their compass lies from geographic north at any given location. Across the surface of the planet, there are lines where this variation is effectively zero. On these lines, called agonic lines, magnetic north and true north line up. One such agonic line has historically passed through the region we call the Bermuda Triangle. This is not in itself dangerous, but it is different. A navigator used to applying a certain correction might cross into this zone, continue using their habitual adjustment, and inadvertently introduce an error instead of removing one. In the era before GPS and satellite navigation, when positions were often fixed by dead reckoning and occasional celestial sightings, small compass errors accumulated over time could shift a vessel or aircraft miles off its expected track. In poor weather, without visual references, crews could become disoriented, trusting instruments that were slightly but significantly in error. When people later reconstructed these routes on a map, the resulting paths sometimes looked strange or inconsistent with the last known reports. There is nothing paranormal in a misread compass or in a navigator forgetting that they have crossed an agonic line and should momentarily suspend their usual correction. Yet, in combination with poor visibility, stormy seas, and the natural anxiety of being off course in a hostile environment, such errors can feel uncanny. Reports from some incidents in the Triangle mention pilots or captains expressing confusion about their direction, their instruments, or their charted position. A magnetic field that varies across the globe and a line where correction is zero offer a quiet, plausible contribution to that confusion. When you stand back and look at all of these factors together, a picture emerges that is less cinematic than a swirling portal, but in its own way more compelling. In this corner of the Atlantic, weather systems capable of producing sudden, violent storms are common. The sea states those storms generate can, under rare but real circumstances, produce rogue waves tall enough to threaten even large ships. Beneath the water, there may be occasional releases of gas from the seafloor, intriguing but not yet well quantified. Over all of this, The invisible geometry of Earth's magnetic field complicates navigation, particularly for those relying heavily on compasses and mental arithmetic. Each of these elements is understandable within the framework of modern science. Each has been studied in laboratories, on research vessels, by satellites, and over decades of observation. None require an extra layer of mystery. Yet, for the people who find themselves at the center of a convergence, sailing through the night as a storm intensifies faster than expected, instruments beginning to disagree, seas rising into steep, chaotic walls, experiences in this region can easily feel as though they have slipped the bounds of normal explanation. That feeling, that gap between what we expect the ocean to be and what it sometimes is, has been fertile ground for stories. But to complete the picture, we need to consider a final ingredient, one that links all of these natural forces to actual decisions made on bridges and in cockpits. The sea may be difficult, the sky unstable, and the instruments imperfect, but it is human judgment under pressure and often in fatigue that turns conditions into outcomes. When people talk about the Bermuda Triangle, they often imagine forces that remove control from human hands. Yet again and again, when investigators have been able to reconstruct events, they find something quieter and more familiar. They find people making decisions with incomplete information, under time pressure, in environments that are unforgiving of even small mistakes. For most of the period in which the Triangle's reputation was forged, navigation was an art practiced on the edge of uncertainty. Before radar, before GPS, a ship's position on the ocean was often an estimate more than a fact. Navigators relied on what was called dead reckoning. Starting from a known point, they would track their course and speed over time, correcting that mental map with occasional sightings of the sun or stars when the sky allowed. This method works well in stable conditions. It works less well in a region where a strong current like the Gulf Stream can carry you sideways at several knots, where sudden squalls can hide the sun for days, and where magnetic variation quietly shifts beneath you as you sail. A course that looked neat on paper in a harbour office could, in practice, drift dozens of miles off track by the time a ship reached the open Atlantic. For aircraft, especially in the early decades of overwater flying, the situation was even more delicate. Fuel carried in finite tanks, limited endurance, and minimal margin for lengthy searching meant that navigation errors could rapidly become existential. Pilots flying training missions or routine hops out of Florida in the 1940s and 1950s did so without the safety net of continuous satellite positioning. They had compasses, simple radios, and often little more than their watches and their judgment. One of the most frequently cited examples is Flight 19, a group of 5 Navy TBM Avenger torpedo bombers that vanished during a training exercise in December 1945. The mission was not supposed to be dramatic. It was a navigation and bombing practice run, out from Fort Lauderdale, over the Bahamas, and back again. The weather at takeoff was acceptable. The aircraft were in working order. The crews were experienced, though some were still in training. But there were vulnerabilities built into the flight before the wheels left the ground. The Avengers were not equipped with the kind of radar later generations would take for granted. The training aircraft lacked even basic 24-hour clocks that would have allowed the pilots to time their legs accurately. As they flew east over the water, clouds thickened, Visibility changed, and the only sure reference points were the compasses in their cockpits and the mental maps in their heads. At some point on that mission, the leader became convinced that his compasses were no longer reliable. He reported that both were out, pointing to conflicting headings. In the radio transcripts that survived, investigators later heard a man trying to reconcile what his instruments were telling him with what he believed he should be seeing. He thought he recognized the islands below as part of the Florida Keys, when in fact the best reconstructions suggest he was more likely over the Bahamas, to the east of Florida rather than to the west. It is a small error on a large map, confusing one chain of low sandy islands for another in a grey sky. But once that mental switch was thrown, every subsequent decision was shaped by it. Routes were reversed or altered in an attempt to reach a coastline that the pilots believed lay in front of them, but that, in reality, was behind. As fuel burned down, anxiety rose. Radio chatter became more uncertain, more fragmented. The Navy board that later examined the loss of Flight 19 did not invoke supernatural causes. It spoke instead of mental aberration, by which they meant not madness, but a cascade of cognitive errors under stress. Pilots misinterpreted their compasses. They misjudged the weather and its effect on visibility and drift. They tried to make route planning decisions on the fly, in poor conditions, with limited instruments, and without a clear shared picture of where they were. These themes recur in other Bermuda Triangle incidents where records survive. Captains sailed into weather that, on later analysis, seems clearly too severe for their vessel's condition. Aircraft pressed on into deteriorating visibility because turning back felt, in the moment, like an admission of failure or an unnecessary delay. In some cases, navigators continued to apply their usual magnetic corrections, even as they crossed the agonic line where such corrections were no longer appropriate, introducing errors instead of removing them. That magnetic line, where true north and magnetic north briefly align, does not, by itself, cause ships to vanish, but in the days before electronic charts and automatic corrections, it could act like a subtle trap for habit. A navigator accustomed to adding or subtracting a fixed number of degrees to compensate for local magnetic variation might, out of routine, keep making that adjustment in the agonic zone. The resulting course would be slightly but meaningfully off, and over hours of travel that offset could carry a vessel or aircraft away from its intended path. Layer on top of these technical issues the human experience of the open ocean, and the potential for confusion deepens. For those who are not used to it, the sea can induce a kind of cognitive disorientation, sometimes described as nature shock. On land, we are surrounded by fixed references: buildings, hills, roads, trees. In the middle of the Atlantic, there is only water and sky, both in constant motion. When clouds lower and the horizon fades, it becomes surprisingly easy to lose any intuitive sense of direction. Wind shifts, rain curtains the view, and waves march in patterns that may have little to do with the actual track of the vessel beneath them. Pilots flying over such seas, especially at night or in heavy weather, must often rely entirely on instruments that may not agree with their inner ear or their expectations. The human brain, faced with this mismatch, is prone to illusions, to feeling as though the aircraft is banking when it is level, or as though it is climbing when it is in a steady descent. Modern training emphasizes these phenomena and drills crews in trusting their instruments over their senses. Earlier generations did not always have the same level of systematic preparation, especially in wartime or in the rapid expansion of commercial flying. Accounts from Triangle incidents include descriptions of crews expressing confusion, not just about where they were, but about which way they were turning or whether they were over land or sea. In calm daylight, such mistakes might be corrected before they became dangerous. In a storm, at night, with fuel running low, they can be fatal. Yet even here, it is important to maintain a sense of proportion. Not every ship or aircraft lost in the Triangle can be neatly assigned to a specific error or decision. Some wrecks have never been found. Some final transmissions were too brief, too garbled, or never recorded at all. In those cases, investigators can point only to patterns, a history of misjudged weather, a region where compass interpretation required care, routes planned with thin margins through waters known for sudden storms. These patterns are not unique to the Bermuda Triangle, though they have been woven particularly tightly into its myth. Human factors, fatigue, overconfidence, cautiousness that tips into indecision, are present in accident reports from every ocean basin. What the Triangle offers is a highly trafficked, meteorologically active region in which those vulnerabilities were tested often and sometimes exposed with tragic clarity. Over the last few decades, the technological environment in which those tests occur has changed dramatically. Satellites now keep continuous watch over the Atlantic, feeding weather models that can predict the development and track of hurricanes and tropical storms days in advance. Ships and aircraft can receive real-time updates about squall lines, wind shifts, and sea states, rather than relying solely on barometers and occasional radio reports. Global positioning system receivers, working in concert with other satellite navigation constellations, provide position fixes that are accurate to within meters. Modern avionics integrate these signals with inertial reference systems, autopilots, and moving map displays. Even if a pilot were temporarily unsure of what the clouds outside were doing, the instruments in the cockpit would show with quiet precision the aircraft's latitude, longitude, altitude, and heading. On the bridges of commercial ships, electronic chart displays overlay GPS positions onto detailed digital charts. Automatic identification systems broadcast a vessel's identity and course to others nearby. Radar paints the outlines of land and squalls on screens. Echo sounders report depth beneath the keel. Communication systems link captains to shore-based operations centers around the clock. These tools do not eliminate risk, but they transform its texture. They yield kinds of navigation-related errors that plagued early Triangle incidents: dead reckoning drift, misapplied magnetic corrections, uncertainty about basic position, are now much easier to detect and correct. When analysts examined decades of recent Coast Guard casualty data, they found that the Bermuda Triangle does not show an excess rate of mysterious losses compared to other busy ocean areas. Incidents still occur, but at frequencies that match what would be expected for any heavily traveled region subject to storms and heavy traffic. And yet, occasionally, a modern disappearance in or near this part of the Atlantic still makes headlines. A small cargo vessel fails to arrive. A private aircraft drops off radar. In 2017, a Turkish Airlines cargo flight en route between continents had a serious incident that briefly ignited speculation, simply because its route passed through the broader triangle area. Investigations may later identify mechanical faults, severe weather encounters, or other concrete causes. But by then, the story has often already slipped into the gravity well of the legend. There is a gap between what the statistics say and what the human imagination feels. The numbers suggest that, with GPS, satellite weather, and advanced avionics, the Bermuda Triangle is no more dangerous than other busy sections of ocean. The stories, however, linger on moments of radio silence, last known positions, and maps with dashed lines that end over deep water. Mystery, once attached to a place, is remarkably resilient. In that sense, human judgment remains central not only to what happens at sea and in the air, but also to how we interpret it afterwards. We now have more tools than ever to navigate safely through these waters. We also have more information than ever to show that their hazards are natural and broadly understood. Yet the idea of a cursed corner of the Atlantic persists, as though some part of us prefers an unsolved puzzle to a set of overlapping, very human explanations. To understand why the legend has endured so powerfully, even in an age of satellites and data, we need to leave the charts and weather maps behind for a moment and look instead at the stories we tell, the books we read, and the way a single dramatic narrative can outweigh 1,000 uneventful voyages in the human mind. In the mid-1970s, long before search engines and social media, a single book stepped into that space between data and imagination and gave the Bermuda Triangle its modern shape. The author was Charles Berlitz, a linguist and popular writer with a taste for the mysterious. His book, simply titled The Bermuda Triangle, appeared in 1974. It was not the first time people had linked odd incidents in this part of the Atlantic into a pattern, but Berlitz did something new. He gathered decades of scattered stories, missing freighters, vanished military flights, inexplicable distress calls, and wove them into a continuous narrative. The timing was perfect. Commercial air travel was expanding, Cold War anxieties simmered in the background, and there was a growing appetite for tales that hinted at hidden forces beneath the everyday world. Berlitz's book suggested, with a tone of grave curiosity, that something unusual was happening in the triangular stretch of sea between Florida, Bermuda, and Puerto Rico. He did not prove that a supernatural force was at work, but he gave readers a sense that the official explanations were unsatisfying, that there might be more beneath the surface. The book sold astonishingly well. Many sources estimate around 20 million copies in some 30 languages. That kind of reach transformed a regional maritime curiosity into a global modern myth. Readers who had never seen the Atlantic, who might never board an ocean-going vessel, suddenly knew the phrase Bermuda Triangle. Mapmakers began labeling the area on novelty charts. Travel brochures occasionally leaned into the theme with a wink. The idea of a cursed or haunted patch of ocean, once obscure, entered common speech. From that point on, the Triangle lived not just in accident reports and weather charts, but in culture itself. Berlitz's book inspired a theatrical film in the late 1970s, then a documentary that blended interviews, reenactments, and ominous narration. Television producers discovered that any episode framed around the Bermuda Triangle reliably drew an audience. Magazine covers in the 1970s and 1980s featured dramatic paintings of ships sliding beneath towering waves, aircraft disintegrating in flashes of unearthly light, headlines that asked whether science could explain the mystery. Pop culture followed, as it often does, with more playful takes. Animated shows sent their characters on misadventures through the triangle. Board games and early video games used it as a backdrop, turning missing ships and storms into obstacles and levels. Songs and novels dropped the phrase into lyrics and plots, trusting that listeners and readers would feel instantly the mix of danger and intrigue it carried. Through all of this, the real ocean continued to behave according to its own laws. Storm seasons came and went. Ships and planes crossed the region by the thousands, almost all without incident. Investigators who studied actual cases pointed to severe weather, human error, occasional mechanical failure. As we have seen, modern analyses of Coast Guard records and insurance data suggest that the rate of incidents in the triangle is comparable to other busy ocean regions. NOAA, the United States agency that studies the sea and atmosphere, has been clear in its public statements. There is no evidence that disappearances occur more frequently there than anywhere else with similar traffic and conditions. Yet the cultural momentum that Berlitz helped create did not depend on those numbers. It depended on stories. As long as there were a handful of strange cases, ships that sent a single confused message and were never heard from again, small aircraft that disappeared between routine radio calls, there would be raw material for new retellings. In the decades after the book's release, each new documentary or special tended to follow a familiar pattern. First, a montage of dramatic incidents. Flight 19, the USS Cyclops, a pleasure yacht found drifting without its crew. Then, a survey of possible explanations presented in a way that allowed the most exotic possibilities to linger in the viewer's mind. Some programs leaned hard into paranormal speculation, invoking aliens, time warps, or ancient crystal technologies. Others framed themselves as skeptical, but even skepticism, when packaged for entertainment, can reinforce the sense of mystery by repeating the same set of incidents again and again. Print media played a similar role. When a magazine devoted a few glossy pages to the triangle, it rarely led with dry statistics. It led with an arresting photograph and a headline that implied a puzzle. Within the article, a paragraph reminding readers that experts found nothing anomalous in the data might be sandwiched between more memorable paragraphs about ghost ships and inexplicable compass spins. As the media landscape changed, the legend adapted. Cable television brought dedicated channels for documentaries and so-called mysteries. The Bermuda Triangle became a recurring topic, a reliable entry in series with titles that promised strange but true stories. Even when individual episodes took a cautious tone, the marketing leaned into the aura of the unknown. Then came the internet, and with it, new ways for stories to spread. Now, anyone could post a list of top 10 unsolved disappearances, or share a map with a red triangle and a caption urging viewers to explain this. Short videos, urban legend forums, and social feeds amplified the triangle anew. Misinformation could travel quickly. One widely shared meme claimed that 90% of planes and ships that enter the triangle never return, a statement completely at odds with recorded traffic and safety data, but effective as a startling image. In this environment, the Bermuda Triangle became something like an early internet meme, a cultural reference that can be used seriously, jokingly, or as a shorthand for any mysterious disappearance. Jokes about misplacing keys or losing socks to the Bermuda Triangle coexist with more earnest posts, asking whether recent accidents might be connected to a hidden force. The legend lives at many levels at once, from light-hearted metaphor to deeply felt suspicion. Why does it endure so strongly when the evidence for a unique anomaly is so thin? Part of the answer lies in the way human minds handle risk and chance. Long stretches of normalcy rarely leave an imprint. Thousands of safe crossings through a storm-prone region become, in our memory, a single idea. Nothing happened. A single dramatic loss, especially if the details are confusing or incomplete, becomes a gripping narrative. Stories of unexplained loss, a radio call cut off mid-sentence, a last known position over deep water, are easier to remember and retell than explanations that hinge on probability, equipment failure rates, or subtle weather patterns. We are also drawn to gaps in knowledge. Even when investigators can reconstruct most of what likely happened, there are often final minutes that remain unrecorded. In that empty space, imagination thrives. It is more emotionally satisfying in some ways to believe that a ship crossed an invisible boundary into an altered realm than to accept that it probably succumbed to a powerful storm, unseen in its last moments by anyone who survived to describe it. Mysteries like the Bermuda Triangle offer something else as well, a way to personify vast, indifferent systems. The Atlantic Ocean is enormous, dynamic, and, to individual humans, uncaring. To think of one region of it as cursed or enchanted is to give that immensity a face, a name, a story. It becomes not just water and wind, but a character in a shared mythology. On the other side of the scale lies the quieter reality of statistics and maritime risk. When researchers subject triangle incidents to the same careful scrutiny they apply to accidents elsewhere, patterns appear that are entirely terrestrial. The region sits along major shipping lanes and flight corridors. It lies within the reach of tropical cyclones. It includes shallow banks and deep trenches, tricky currents and areas of magnetic variation. It is, in short, a challenging but comprehensible environment. Analyses that compare incident rates here with those in other high-traffic ocean zones find no persistent, unexplained excess. Some years see more losses, others see fewer. The curves rise and fall with weather cycles, technology changes, and safety practices. Sailors and pilots who work these routes professionally understand that the risks they face are those of the sea and sky in general, concentrated somewhat by geography, but not transformed into something fundamentally different. And yet, for most of us, it is not the actuarial tables that seep into our dreams. It is the ghost stories, the unanswered calls, the sense of a triangular void on the map that swallows evidence as well as vessels. This tension between the emotional appeal of a grand, unresolved mystery and the sober, often prosaic findings of investigation is at the heart of why the legend keeps resurfacing. In the end, the Bermuda Triangle appears to be less a supernatural zone than a mirror. It reflects back to us our relationship with the sea, our awe at its power, our respect for its dangers, our discomfort with randomness and loss. It also reflects the way information moves in our culture. A few dramatic events, amplified by a best-selling book, echoed by films and television, and now endlessly recycled in digital form, have created a story that feels larger and stranger than the evidence beneath it. That does not make the triangle uninteresting. On the contrary, it remains a compelling window into how we experience oceanic risk and how our imaginations respond to the unknown. Within its boundaries, real storms still form, real waves still rise, and real navigators still have to make careful choices. Around its edges, our stories continue to swirl, some grounded in data, others drifting free. As you drift towards sleep, you might hold both of these images at once. The dark, restless waters of a well-traveled ocean, governed by physics and chance, and the glowing outline of a triangle drawn on a map by human hands, filled with decades of whisper and wonder. The first belongs to the world as it is. The second belongs to the world we build in our minds. If you've enjoyed this quiet journey through those overlapping worlds, it would mean a lot if you gently tap like, leave a comment, and subscribe for more nights at sea. And before you drift off completely, let us know in the comments where in the world you're listening from tonight.